This is my final project for ISTA 322, titled Exploring Income and Electric Vehicle Ownership in Washington. So, for this project, I explored the correlation between income level and electric vehicle ownership, and also general statistics about electric vehicle population in the US state of Washington. For this, I basically searched for appropriate data sets and found one for electric vehicle registration in Washington and another for median household income for all cities in Washington. So, my first data set is from the US Census Survey, American Community Survey 5-year data set, which contains a lot of data about social, economic, housing, and demographic characteristics of US population from 2009 to 2023. Um, I used the data on median household income in the past 12 months for 2023, which is the latest available year for all cities in Washington. They also have a public API with an optional key, which I used for this project. Some challenges that I encountered were that the city column had different format than the other dataset which I use, so I had to change that to match for both the datasets. There were also certain jam values in the income column, which basically represented income higher than 250,000 per year. So the actual income level for those records were not mentioned. Instead, it was represented by certain values. So I had to remove those from the dataset. The second dataset is the electric vehicle population dataset, which I found from data.gov. It contains battery operated electric vehicle as well as plug in hybrid electric vehicle registration in all cities in Washington, and it's updated as of November 2025. It has a lot of attributes, including electric range, base, MSRP, model type, as well as the EV type. Some challenges I encountered were that there was a particular city name which appeared with different capitalization, and that later created problem when I was loading data into SQL due to primary key integrity. There were also certain records for which the base MSRP and range had zero value, which actually represented a missing value as per the data sheet. So during cleaning and transformation for the electric vehicle population dataset, I filtered columns, null values, missing values, removed the capitalization from cities, and also selected only those records which had battery electric vehicles. So I did not use the hybrid vehicles basically. I then aggregated the whole table by city name and differentiated into two normalized datasets. The first dataset contains EV population as well as the most popular EV per city. And the second dataset contains the average range and average base MSRP per city. For the second census ACS 5 dataset, I again filtered columns, filtered negative income values, converted some data types, removed capitalization from city name again, and formatted the city column to match the electric vehicle population dataset. Um, I also filtered city names and um, only used those which are present in both the datasets. And I also removed the jam values that was mentioned earlier from the median household income column. So this is my data schema. I have basically three data sets that are loaded into the SQL database. EV population has primary case city, which is basically referenced by the city column in the other two data sets, which can be seen here. So for queries, for the first query, I basically explored the relation between household income and number of EVs in cities with at least 100 electric vehicles. Um, I chose cities with at least 100 vehicles so that it represents cities with significant EV population. Um, you can see there might be a weak correlation between the EV count and median household income, but it's nothing clear as such. For the second query, I explored the relation between the average base MSRP, which is the manufacturer suggested retail price, and household income. Uh, Again, the data is spread around, but there's kind of a weak trend with higher household income tending to buy EVs with higher base MSRP. Um, for the third, I basically explored the five most wealthiest cities with at least 10 electric vehicles where Tesla is not the most popular EV, because for most of the cities, Tesla is the most popular brand. So for this one, I, I chose to see those cities where Tesla is not the most popular EV. For the fourth query, I explored the average range to price ratio in the top 10 cities with most number of electric vehicles. And for my fifth query, I basically explored the distribution of most popular electric vehicle for all cities. Basically, um, the number of cities where each EV brand is the most popular electric vehicle. As can be seen, Tesla is clearly overwhelmingly the most popular electric vehicle for a lot of cities, which is followed by Chevrolet and Ford. So that's my whole final project for this course.